This is a video lesson that wraps up the end of the lesson today that I kind of forgot to do because I forgot the graphing part of the lesson. So add this to your notes. If you need to pause and open your notebooks, go ahead and do that. In fact, you can pause the video anytime you need to stop and write something down. So let's start with the graph here. Let's suppose this is a graph of some function and it goes off infinitely to the top and bottom and it keeps moving further and further to the left. This would have a domain of all real numbers, negative infinity to positive infinity, because I can go left as far as I want and right as far as I want, and a range of all possible y values, because I can go from negative infinity to positive infinity in the y direction as well. This can go down very, very far, and this can go up very, very far. Furthermore, it is a function because no matter what value of x I pick, I can go to the graph in the y direction and only find one value of y, never more than one. Now watch how different that is from this graph. Now on this graph, if I pick a point of x right here, I can find a point with that x coordinate up here and another one with its x coordinate down here. That means for the same x, maybe that's -3, I have two different y values, one up here and one down here. That is, for one input, I have two outputs. This is not a function. It's what we call a relation. It fails what you may have learned in high school is called the vertical line test. That is, if you can draw a vertical line through a graph and it touches the graph at two or more places, then that means you do not have the graph of a function. For example, the most obvious one here is the y-axis. It intersects the graph there and there. That means for an input of x equals 0, we get an output of y equals 5 and y equals -5, for example. Over here, no matter where you draw a vertical line, it'll only intersect the graph once. So this is a function. This graph fails the vertical line test, so it's not a function. Okay? So what about that little vertex right there? Well, maybe that's the point 5, 1. If it is, see if you can write down the domain of this function. Go ahead and pause the video, and then when you come back to it, I'll give you the answer. Okay, you're back. The domain of this function, well, let's examine the x direction. I can go as far as I want to in the negative x direction. Assume again that we have arrowheads on here. But as we move to the right, it stops right there. Nothing to the right of x equals 5. So that means that our domain is from negative infinity to positive 5. That is, all the x values at 5 or less will work. What about the range? Again, pause the video if you need to and write that down. Okay, you're back. The range, as you probably figured out, is all real numbers from negative infinity to infinity, because as we keep moving left, this part gets higher and higher, and this part gets lower and lower. And so we cover all the values of y, and that's what the range is. All right? Okay, let's take a look at another kind of function. You think this one's pretty cool. That's sweet, isn't it? Is that in fact a function? Well, let's try the vertical line test. A vertical line crosses here, 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 only crosses once, over here also. What about this weird area in here? Well, this weird area in here, the vertical line touches the function there, but doesn't touch the function here because that's an open circle, a hole in the graph. So once again, the vertical line only touches once. This is a function. In fact, it has a special name. This is called a piecewise function. And you can see why it's in two pieces. You want to know what the rule for a piecewise function might look like? Well, it could look something like that. Maybe you've seen something like that before. This splits the domain into two places. In this case, to the left of 2 and at or to the right of 2. All in all, it covers all the real numbers from negative infinity to infinity, which just gave you an answer to a future question. And it in fact includes the number 2 right here. Now, what would the graph of this look like? If you think you know, pause the video and sketch it. Okay, here it is. The graph of this piecewise function looks like this. Is that weird or what? The idea is this. To the left of 2, that's to the left of x equals 2. That means over here, it's the graph of y equals -3x, a slope of -3 and a y-intercept of 0. And it even comes down here to -6. If I plug in 2, I get -6, right? Except you'll notice the hole there because x is not allowed to equal 2, at least for this piece of the function. For this piece of the function, which is at 2 and to the right, it's the graph of y equals x plus 1. Now, the y-intercept doesn't exist for this part of the function because x can't be 0 for this part of the function. It would have been 1, but a good way to figure out is this. If I plug in a 2, which I'm allowed to do now, I get that it's at a height of 3. So we have the point 2, 3, and then it has a slope of 1 over 1. So I go up 1 and over 1 and continue drawing the function. That's our piecewise function written as a rule and drawn as a graph. Now the domain we've already discussed. The domain goes from -infinity to infinity. It just splits the domain at 2, but it still includes the number 2 on the bottom piece of the function. Another way of thinking about it is you can pick any number for x and plug it into the function and you'll get some answer. The range is a little trickier though. You might want to pause the video and see if you can write down the range. Okay, so you're back. Maybe you saw that nothing in the y direction goes below the value of -6, but it goes up as high as you want it to. So that means that the range is from -6 to infinity. Make sense? Do you know why there's a parenthesis here? That's right, because there's an open circle here. So it actually isn't ever allowed to equal -6, but it's anything above -6. If we were writing it in other notation, we would write x is greater than or equal to -6. No, we would write it as x is greater than -6. All right, so that's the end of your lesson. Good luck with the homework. Bye-bye.